Welcome to the WION podcast, where we explore fascinating stories and ideas from various fields. In this episode, we uncover how scientists have confirmed that time on Mars actually ticks differently and that it proves Einstein right on the red planet. Because as humans prepare to live and work on Mars, even a tiny time gap could turn into a big mission problem. Physicists at the National Institute of Standards and Technology, NIST, have calculated that clocks on Mars tick 477 microseconds faster per day than clocks on Earth. This is because of Mars's stretched orbit and gravitational influences from other bodies. It has also been discovered that the time difference can vary by as much as 226 microseconds per day throughout the Martian year. The idea has been sourced from Albert Einstein, who showed that time is not the same everywhere in the universe, as the rate at which a clock ticks heavily depends on gravity, showing that clocks run slightly slower where there is a stronger gravity and faster in weaker gravity. In addition, time coordination across Earth is complex and extends across the solar system, which is far more challenging. The study, recently published in the Astronomical Journal, builds on a 2024 paper in which scientists at the National Institute of Standards and Technology, or NIST, proposed a framework for ultra-precise timekeeping on the Moon. NIST physicist Bijunath Patla said that accurately measuring time on Mars will be vital for future missions. Mars follows a markedly different rhythm from Earth, as a Martian day is roughly 40 minutes longer than an Earth day, while a Martian year lasts 687 Earth days, compared with 365 on Earth. Beyond these differences, scientists needed to determine whether time on Mars flows at the same rate as it does on Earth. An atomic clock placed on Mars would operate normally and tick just as it would on Earth. The challenge arises when that clock is compared with one on Earth, as the two gradually fall out of sync. Researchers, therefore, had to calculate the precise offset between the two, similar to defining a planetary time zone. The task proved more complex than anticipated. Under Einstein's theory of relativity, gravity influences the passage of time, with clocks running slower in stronger gravitational fields and faster in weaker ones. A planet's motion through space also affects time, as orbital speed introduces additional variations. To carry out the calculations, NIST scientists chose a specific reference point on Mars, similar to sea level at Earth's equator. Drawing on data collected from decades of Mars missions, Patla and fellow NIST physicist Neil Ashby estimated the planet's surface gravity, which is about 5 times weaker than Earth's. However, Mars's gravity alone did not provide the full answer. The solar system is a constantly shifting environment in which massive bodies exert gravitational forces on one another. The Sun, which holds more than 99% of the solar system's mass, plays the dominant role in shaping planetary motion. The position in the solar system, which includes its distance from the Sun and interactions with neighboring bodies such as Earth, the Moon, Jupiter, and Saturn, results in a more stretched and elliptical orbit. In contrast, Earth and the Moon follow relatively stable orbits. As a consequence, time on the Moon runs consistently about 56 microseconds faster per day than on Earth. But for Mars, that's not the case. Its distance from the Sun and its eccentric orbit make the variations in time larger. A three-body problem is extremely complicated. Now we're dealing with 4: the Sun, Earth, the Moon, and Mars, NIST physicist Bijunath Patla explained. The heavy lifting was more challenging than I initially thought. After factoring in Martian surface gravity, orbital dynamics, and the gravitational influence of the Sun, Earth, and the Moon, Patla and Ashby reached their final calculation. Thanks for tuning into this incredible story. If this episode resonated with you, don't forget to hit the like and subscribe button for more captivating stories to come. Stay tuned.